So a rotation is a transformation in which a figure is rotated about a point called the center of rotation. The number of degrees a figure rotates is the angle of rotation. So if you take a look down at our picture down here, you can see the original trapezoid here in red, and it's being rotated around this point here, the center of rotation, and it looks like they're going clockwise, looks like about 90 degrees, but whatever that degree is down here, that's the angle of rotation. So let's take a look at this example problem. The vertices of a triangle are J, K, and L, and as you can see, they've given us the coordinates for those points. They want us to rotate the triangle 90 degrees counterclockwise about the vertex L. What are the coordinates of the image? Alright, so let's have a look at how we would do that. Alright, so first thing, of course, we would do is graph the triangle they're asking, which is 1, 2, so that's J, 4, 2, which is K, and L, which is 1, negative 3. Alright, so there's our triangle. Now, one thing that may help you here is a tool that I like to use, which is basically transparency paper. You will have this available, and the idea is that by tracing over our image and then rotating it, that we might be able to better see how to do this. And eventually we won't need the transparency paper at all. But here's how I suggest you use the transparency paper. First off, what I would do so that you've got some reference points is take a transparency paper and just fold it in half. Give it a nice good crease and then fold it in half the other direction. Okay, basically what you want to end up with is a cross on your paper. Okay, because that way what I can do is I can line up this point right here, basically the origin of my XY axis here, with my rotation point, which in this case is the vertex L. So in this case, we're using a part of the triangle as the rotation point. So what I can do is notice how I'm going to line up this point. In fact, I think I'll mark it here so you can see it better. There's our point. I'm going to put that directly over L. All right, and notice how I'm lining it up with J. I'm going to do this one point at a time. So here's J. Now, the instructions said rotate the triangle 90 degrees counterclockwise about the vertex L. All right, so now this is why it makes sense to fold those lines, because these are 90-degree angles if I fold it in half both directions. And now what I'm going to do is I'm going to use my pencil to just hold things down at L, and then I'm going to rotate my paper 90 degrees counterclockwise. So now this line lines up where this one used to be. And so I can see that 90 degrees counterclockwise will put me right there. And so I can mark J prime like so. Okay, and then I can begin again. This time, I'm going to do it with K. Now, K is a little trickier because it's at an angle. And in fact, let's just X this one out. Again, though, what I'm going to do is I'm going to take this point, I'm going to put it on my point of rotation, L. I'm going to line up this crease with K. And then I'm going to put a dot. I'm going to hold my transparency paper down at K, and I'm going to rotate it counterclockwise 90 degrees until this crease lines up with K now. So I've gone full 90, and as you can see, that puts me right here. So if I lift up my paper, there's K prime. And then L, since it is my point of rotation, L is also L prime, so there's no need to rotate it. Now once again, the way to check for things is that if I join it back together, what I should see is a congruent triangle that's been rotated, and in this case specifically 90 degrees counterclockwise, okay, which is what we have. Okay, and you can see how the transparency paper really can be of help. This gets kind of tricky if you don't have that at your disposal, but with practice you get there.